So if you follow the same approach for the other two functions, you'll find these 6 derivatives. We have derivative of arcsine, arccos, arctangent, arccosecant, arcsecant, and arccotangent. Now let's look at some examples. In the first example, we want to find the derivative of arctangent of arcsecant of square root of x. Here we have a function inside of a function, which is inside of another function. The outermost function is the arctangent. So let's start with that, and let's call the inner function as u of x. Then the derivative of the entire function would be derivative of arctan, which is 1 over 1 plus u of x squared. Then since u is a function of x, so we multiply by derivative of u using the chain rule. And this equals, let's substitute the u back, we get 1 over 1 plus arcsine of square root of x squared. Then times derivative of u. Derivative of arcsine is 1 over square root of 1 minus the inner function square. Inner function is square root of x, so its square is x. Then we multiply by derivative of the inner function. Derivative of square root of x is 1 over 2 times square root of x. In the second example, we want to find derivative of y. Y equals a to the power of arcsine of x plus cosine of e to the power of x. So y prime. The first term is a to the power of a function of x. And just a quick recall, derivative of base to the power of a function of x, this equals b to the power of u of x times line of b times derivative of the inner function. So here the base is a, and the inner function u of x is arcsine of x. So the first term, it equals to a to the power of arcsine of x, then times line of b, and b here is the a, and times derivative of the inner function, which is 1 over square root of 1 minus x squared. And the second term, we have cosine of e to the power of x. Derivative of cosine is negative of sine. So minus sine of the inner function, e to the power of x, then times the derivative of the inner function, which is still e to the power of x. Now let's look at the third example. We have f of x equals to sine of arcsine of x, and we want to find the derivative of f of x. Here you can use the chain rule, find the derivative of sine, and multiply by the derivative of the inner function. Or you can realize that we have sine function of its inverse function. They can kind of cancel out when we have a function of its inverse function. So f of x also equals to x. So f prime also equals to 1. Now let's look at the last example. Cosecant of xy equals to x squared times y. Here we have an equation that includes x and y, but it is hard to write y as a function of x. It is impossible to isolate for y and write y as a function of x. So we have to use implicit differentiation. We take derivative on both sides and then isolate for y prime. On the left-hand side, if we take the derivative of arcsecant equals to negative of 1 over the inner function, x times y, then the square root of 1 minus the inner function squared. And since x times y is a function of x, so we have to use a chain rule. Multiply this by the derivative of x times y. and this equals to derivative of x squared times y. We use the product rule here. We get 2x times y plus x squared times y prime. And what is this derivative here? We use the product rule. It equals to y plus x times y prime. Then we can isolate for y prime. We have y prime here and y prime here. I isolate for y prime and move all the other terms to the other side. I have negative of x divided by absolute of x times y, square root of 1 minus x times y squared, and minus x squared. And this equals 2xy plus y divided by absolute of x times y and square root of 1 minus x times y squared. And don't forget the y prime on the left hand side. And the last step is to isolate for y prime. So I move the terms in brackets to the right hand side. I get 2xy plus y divided by absolute of xy times square root of 1 minus xy squared. And divide the whole thing by negative x divided by absolute of xy square root of 1 minus xy squared minus x squared. And of course, you can put them in common denominator and make this look prettier. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.